section 7 now. Remember we did section 5 earlier. I'm skipping 4.6 altogether. So we are jumping down to 4.7 now, which is optimization. Everybody loves word problems, right? Okay, so when we are working on this, we have several steps that we need to be able to go through. First thing, we need to be able to figure out what we are trying to maximize or minimize. We need to know what our variable is. So if you read a problem and you can't tell me what you're solving for, there's really no hopes that you're going to be able to find it, right? So you have to be able to read it and know what you're looking for. We do not want multiple variables in a problem. Just like always, everything has to be in terms of one variable. We don't want to try to find an x, y, and a z all at once. Then, optimization, we'll be looking for maximums and minimums. Maximums and minimums happen where? Thinking about calculus. We did all that graphing stuff on the last chapter. When the derivative equals 0. So we will be using maximums and minimums, critical points, when the derivative is 0 to find it. And then making sure, of course, that we answer our original question with a sentence, because if I give you a problem in words, I'd like you to answer it in words. Okay, so here is our first problem. Some of these questions I actually stole from your college algebra when I did these problems in college algebra. And then we were only dealing with quadratics, and we were able to find everything by doing a vertex. Now we're doing the same types of problems, so I'm using some of the same examples, but we're just going to use the calculus to find it. To find a vertex, that's when the derivative is 0. So they look familiar, that's why. You have seen problems like these before. A farmer has 200 yards of fence to construct 3 sides of a rectangular pen. An existing long straight wall will form the 4th side. What dimensions will maximize the area of the pen? So, how do you think I should start this problem? Picture. I agree. Let's draw a picture. So we have a wall for one side, and we are putting fence on 3 sides here. Okay, we know if it's a rectangle, these sides are obviously the same. This one would be different. Now, can I keep x and y both in my problem? No, so I need to figure out something to replace my y with. So let's think about the information that we know. We have 200 yards. So where does that come into play? If you add these up, it would have to equal 200. So my other side is 200 minus 2x. So I'm just going to replace that. We don't want x and y here. I tried to give you guys a blank slide next to each of these examples too, so if you need a little extra space, you can use that. Okay, then, what am I trying to maximize or minimize? Area. So we'll be setting up an equation for that. If I asked you what answers would be reasonable, I didn't, but let's say I had. X has to fall between which numbers? Can you tell me? It would have to be bigger than 0. Smaller than what? Actually has to be smaller than even that. 100. Why?
Because you have to multiply by 2.
Yeah. Essentially, if I ever ask you for your restrictions on x, we know this side has to be a positive, so it's got to be bigger than 0. If you set your other side equal to 0, 200 minus 2x equals 0, you get the 100. So I would know if I had multiple critical points, you might need to do this just so you know which critical points would make sense. That's probably not going to happen on this problem, but just a good thing to mention. So we want to maximize area. How do you find area of a rectangle? Length times width. So that would be x times 200 minus 2x here. Or if we want to distribute, that's 200x minus 2x squared. Okay, then what should I do to that to maximize or minimize? Derivative. So a prime would equal 200 minus 4x. And you want the derivative to equal 0. Divide by 4 and x is 50. So I only got one answer. Is that a reasonable answer? Yes. We already know because we said x had to be between 0 and 100. But if we hadn't said that, you could even plug it back into both sides and make sure it made sense. Then we have to answer the question. I wanted what dimensions will maximize the area. So the pen should be 50, we were in yards, by, to find the other side, 200 minus 2 times 50. So 200 minus 100 is 100 yards. So those are the final dimensions to answer my question. So far, so good. I would like for you guys to do the next one on your own. It's very similar, so give that one a shot. Okay. Let's make sure you have at least the correct setup here. So we have a rectangular corral. Some of the fencing will be used to construct two inner divider fences, both parallel to the same sides of the corral. So we have two fences in here. What's the maximum area? So same type thing as last time. However, do I have to fence all four sides this time? Yes, plus the two in the middle. So if I call this x and this y, both of these would also be an x. So if I add everything up, we have a 4x and a 2y to equal 1,000. So 2y equals 1,000 minus 4x, divide by 2, so y is 500 minus 2x. Is everybody with me there? If I asked, I didn't, but if I did, x has to be bigger than 0, smaller than 250 if you set the 500 minus 2x equal to 0. Okay, I want to maximize area. So area is length times width, x times y, which in this case would be x times 500 minus 2x. You get 500x minus 2x squared. So then to maximize, you do your derivative. So 500 minus 4x, set that equal to 0. And x is 125. So then to answer the question, we just wanted the maximum area this time, not the dimensions. I wanted the area itself. So you need to plug your 125 into your area equation. And if we put that in, we get 31,250. What were my units? college algebra? You know, you had a sheet of metal and you cut out the corners to make a box, and then I would ask you something about the volume of the box. We're gonna do one of those. So a piece of sheet metal is rectangular, 5 feet wide and 8 feet long. Congruent squares are to be cut from its 4 corners. And the resulting piece of metal is to be folded and welded to form an open top box. So basically you cut out those corners and you fold up the tabs, and we get this box. Open top, I'm not putting a lid on it. Okay. How should this be done to maximize the volume? Did I tell you how big the squares were? No, but we know it's a square, so all sides are the same. So we could just say that's x. Okay, so when you make this box, this rectangle had a length of 5, but you removed x on this end and x on this end. So how long is it now? Okay. The width was 8, but I took off x here and x here. When you form this box, so you've taken off these squares, you make the fold right here. So when you fold that tab up, how tall is it? X. Everybody with me? I want to maximize volume. How do you find volume of a box? Mm-hmm. So that would be x times 5 minus 2x times 8 minus 2x. I don't want to do a product rule 3 times, so I'm going to multiply this out. I'll start by FOILing these two. So that's 40 minus 10 minus 16, so minus 26x plus 4x squared. Distribute the x. Now if I want to maximize this, we need derivative. So that would be 40 minus 52x plus 64x squared. Wait, not 64, I cubed my 4 instead of multiplying by 3. How about 12? Sorry about that. Did I give you a heart attack for a second? Okay, what do I need to do with that? Set equal to 0. It's a quadratic, so I'm just going to write this in decreasing order. Let's make our life easy. Can we divide by anything to start? 4. Everything's divisible by 4. Let's do that on both sides. We get 3x squared minus 13x plus 10. And then what do we do? Box method. These multiply to 30, add to negative 13. Negative 10 and negative 3. So I get x minus set each of those to 0, we get 10/3 and 1. Okay, I didn't write down what x had to fall between on this one. I could have. But since I failed to, we actually just need to check and see if both of these are reasonable. So if x were 10/3, would that work? Why? What's 5 minus 2 times 10/3?
-1.6.
And -1.6. So if you cut off 10/3 from each side, you now have a negative length, and that's not possible. Could x be 1? Yeah, 5 minus 2 is positive, 8 minus 2 is positive, so 1 is the answer. The question was, how should this be done? So the squares should be 1 foot wide. Let's do another. I want to talk about some of the applications for business and econ, and then that'll probably be, we might do one of those examples and then probably stop for today. So we have talked about cost versus marginal cost before. Several times it's came up. We know that if you have your cost function, marginal cost is how the cost is changing, so it is the derivative of the cost function. When you're talking about marketing, you're not only concerned with the cost. You're concerned with the entire demand function. You want to know, what price should I sell my product for so I can make the most money? And if you're trying to decide how much to charge for your product, you have to consider a couple different things. You have to consider how much is it costing you to make the product, because you obviously don't want to sell it for less than you spent on it. But you also have to find that magical point, because if you charge too much, will people buy it? No. But you want to get the most money out of it you can. If I'm selling it for $2, but people would happily pay $5, wouldn't I rather charge $5? So there's that balance that we're looking for if we're trying to set the price for something. And that's what we're looking at when we talk about the demand function. So price, if you take your price times the number of items you sell, you get your revenue. Revenue is the amount of money you're bringing in. So if I'm going to sell each of you the answer key to the final, and I decide to charge $20 for it, the revenue, the money I bring, would be 20 times 19, because I'm assuming you would all probably buy that, right? So that would be my revenue. I'm not going to, by the way. Okay, if I talk about the derivative, then that gives me my marginal revenue, how my revenue is changing at that point. So how much would my revenue change if I added one more person in here? Maybe somebody from next year wants to buy it. They think I'm going to use the same final, so they're willing to go ahead and buy it now. How is my revenue changing at that particular moment? Then we need to talk about profit, because if I just bring in money, is that all going to be pure profit? No, there's some kind of expense associated with it. Okay, so profit is revenue minus cost. We usually use capital P for profit, and it's revenue, the amount of money you bring in, minus cost, the amount of money you spent to make your product. And profit is ultimately the thing we are trying to maximize. We want to make the most money that we can. So marginal profit would just be the derivative of profit. one example for today, and then we're going to stop. The cost of publishing a book is $10,000 to set up the press run, plus $8 for each book printed. Okay, let's stop right there. Could you write the cost function? It's linear. Y equals mx plus b. M is the thing that gets repeated. What do you have to pay for multiple times? The 8 for each book. So it would be 8x plus, what's a one-time cost? 10,000. So that's how much it's going to cost me to print this book. The publisher sold 7,000 copies last year for $13 each. But the sales dropped to 5,000 copies this year when the price was raised to $15 per copy, which usually makes sense. When the price goes up, fewer people buy it. Assume up to 10,000 copies can be printed in a single press run. How many copies should be printed, and what should the selling price be of each copy to maximize this year's profit of the book? So let's come back to this piece. This is essentially giving me order pairs. When we set this up, X was the number of books, and my Y here was the cost. So when I write those order pairs, I need to make sure I keep X and Y in the correct spot. So what would my first order pair be? 7,000, 13. Second order pair would be 5,000, 15. Okay, this is going to give us our price function, the price that we are charging for it. So we need to write the equation of this line. So y equals mx plus b, start by finding m. y2 minus y1 over x2 minus x1. So my slope is negative 1 over 1,000. How do we find b? Plug it in to take one of your points in your slope, plug in y equals mx plus b. So if I use the first one, my y is 13 equals m times x plus b. So far, we had our cost function. This function, my y value was the price we were charging for each. So here's our price function. A little bit confusing, your book uses lowercase p for price and capital P for profit, so just keep that in mind. So our price is negative 1 over 1,000x plus 20. Okay, we are ultimately trying to maximize profit. Profit is revenue minus cost. I have my revenue, do I have my cost function? Or sorry, I have my cost, do I have my revenue? No, so we need to find that. Revenue, the amount of money you make, is X, the quantity you sell, times the price. Here is my price, so we can get our revenue now. We use capital R for revenue. It's just your price times your quantity. So if I take X times my price function, I get negative 1 over 1,000 x squared plus 20x. Have I lost anyone yet? We want to maximize profit, so I need the profit equation. already told you that profit is revenue minus cost. So, if we work that out, our profit function is the revenue minus our cost, which we wrote at the very beginning, 8x plus 10,000. So if I distribute my 8, or my negative, 20x minus 8x is a 12x minus 1,000. So here is my actual profit function. All that work was to find my profit. Now I want to maximize that, so what do? Derivative. Have I lost anybody on how we got to the profit function? If I bring down my 2 over 1,000 will be 1 over 500 plus 12. And we need to set our derivative equal to 0. So multiply over your 500, and x is 6,000. So 2 questions. How many copies? That is my x. So there should be 6,000 copies. And the price sold for. So if I want to know what price I'm charging, what would I do? Plug it into the price. So our price was right here. So if you plug a 6,000 into that, you get 14. So if I'm going to make the most money possible, then I'm going to print 6,000 copies and charge $14 each for them. Any questions there? We are not done with this section. I am going to give you a few book problems today. I'm not collecting them Monday, but I'm adding to it. So I'm going to give you 3 today and 4 on Monday. So I would strongly recommend doing these. Come in during advisory if you need some help. I've got a few minutes right now. You need to do 3, 7, and 15.